So what's up, guys? Today you will learn about propagation of uncertainties. This is a class of JD Afanador, a physics class. Okay, so my physics teacher just showed me how to do this, so I'm gonna show you guys how to make propagation of uncertainties. So let's get into it. So to start, they are asking us to multiply A times B minus 1. So they are giving us these values. So they are telling us that the value of A is 1982 meters, and its absolute uncertainty is 0.05. And they are also telling us that the value of B is 35,033 meters, and its absolute uncertainty is 0.02. So what do we do with this? They are telling us to multiply these values and these absolute uncertainties. So let's get what we got. So starting with the calculations, what do we do first is just simple. Just multiply the values. Which values? The values of A with the values of B. So as you already know, we're multiplying the values of A, that is 1982 meters, with 35,033 meters, okay? And if we do this multiplication, it's gonna give us this number, quite a long number. So what do we do when we have these numbers? We just look at the decimals, the amount and the least decimals of the two values. So we can see that the least amount of decimals are 4 in the A values. So we're just gonna make our answer in just 4 decimal places, just the only 4 decimal numbers. So the final answer of the multiplication between the values will be 6,943. And remember, this is a mistake almost all the students do. It's not meters, it's meters cube. So remember to put meters cube. So as we already do this operation, we're gonna have the value between the multiplication of A values and B values. That is 6,943 meters cubed. That is something that are gonna ask in the class, in the homework, in the exam. So they are gonna ask you for the value between the operation, and in this case is this number, this. So then what do we do? They are asking us now for the absolute uncertainty of this operation. So what do you see here? We can see the absolute uncertainty, and they are telling us, like, this is kind of the formula. So they are showing us that the way to get the absolute uncertainty is to get the uncertainty of A divided by the value of A, add to the uncertainty of B divided by B, and that is how we're gonna get the absolute uncertainty of our operation. Okay, now using the formula we already know, the formula that was given to find the absolute uncertainty, we just plot each part. So the absolute uncertainty of A, that is 0.05, is gonna be divided by the value of A, that is 1.982, and this is gonna be added with the absolute uncertainty of B, which is 0.02, and it will be divided by the value of B, that is 3.5033. Okay, so if we use our calculators, we're gonna find out that the answer is this number, quite a long number. So as we already know, we're gonna see for the least decimal in the equation. So we can see that the least is 3 decimal points of the 0.05 or of the 0.02. So we're gonna do the same to our answer. So if we do this, we're gonna find out that our absolute uncertainty of A times B minus 1 is gonna be equal to 0.03. But hold on, we're not done yet. So last but not least, we're gonna find the percentage uncertainty. So how do we do this? It's actually not difficult. It's just like a rule you have to know every time they're telling you to find out the percentage of an operation. So as we already know, our uncertainty is 0.03. So we're gonna multiply it with 100%. Okay, so if we do this operation, we're gonna have 3%. So what does this mean? This means that our percentage uncertainty is gonna be equal to 3%. So yes guys, this is a bonus, an extra knowledge bonus. So if in the exam they are telling you, okay, you got us the percentage, but so hold on, we want your answer in meters. So you're gonna think and just gonna say, how am I gonna do that? And that's why I'm here for you. That's what I'm doing for you. So here we're gonna go backwards and remember our first value of our operation. That was 6.943 meters cubed. Okay, and we're not gonna look our last operation of percentage, but we're gonna go one step backward and we're gonna have 0.03. That is our absolute uncertainty. Okay, so we're gonna multiply both to get our answer in meters. So the answer of our operation between the values and the absolute uncertainty is gonna be this very long number, which is so long that I didn't write it all. And I'm not gonna do that. Why? Because we don't really need to. So as we know, we just have to round up. So what are rounding rules? Okay, first of all, we just have to know how much they are telling us to round up to, because it will be 1 decimal place, 2, 3, 4, 5, or even 6, or even 10. So in this case, we're gonna just round up to the first decimal place. Okay, our first decimal place is 1. And to round up, we just need to look at the next number to the right. In this case, it's the 4. So you're gonna ask, like, okay, so I know now the steps, so how do I round up? And thanks to math, thanks to your physics teacher, and thanks to me, you're gonna learn a super mega ultra rule that you can learn. So if the right number is from 4 down, the number that is being rounded, in this case the 1, is gonna stay the same. Okay, but if the number to the right is 5 and up, the number that is being rounded is gonna go up, so it's gonna be add one more. So if in this case the 4 was a 5, a 6, a 7, an 8, a 9, or a 10, it will be 2, but it's not, it's 4. So our rounded number is gonna be 1. So we got the final answer. Things you have to remember: this is the meter number of the multiplication between a times b minus 1. Okay, this is not the value of a or the value of b, which are also in meters. No, this is like the value of a times b minus 1. So we got our final answer. Thank you very much for watching this video, and hello miss, I hope you like this video. See you in the next class. Bye bye.